FZ. Today I'm going to share my learning experience of LeetCode problem number 112, pass sum. So this is an easy problem. Let's jump into the description. Given a binary tree and a sum, determine if the tree has a root to leaf path such that adding up all the values along the path equals to the given sum. Note a leaf is a node with no children. So there is an example. So you are given a summary which is 22, and you need to find all the way from the root to the leaf, such as 7, 2, 13, or 1. Find out if there's any pass, which the summary is equals to 22. So the answer here it is 5 4 11 2, which is 5 4 11 2. So this is the answer. So this is an easy problem. So one of the way to solve this, usually if you're given a tree, lots of times you need to think of like is it possible to solve this by a recursive solution, and lots of times it is. So um, what happened is you uh, you want to kind of break down into a smaller problem. So for example, if let's say this is a small tree only has 3 nodes, for example 11, 7, and 2. What you're doing is you just need to see, okay, if the left child um, plus itself, is this the equals to the final answer? Is the right child plus itself is the final answer? If one of the paths is the final answer, then you need to you can return. Um, you don't have to check the other side. Um, and going if going up one level, it's the same, right? If we want to know, okay, is this pass plus this equals to 22, or 2 plus 11 plus 4 equals to 22, and same as one level above. So this is the code. One of the thought process I have is um, we only need to make sure that any side of the from the root node is returning true. It will treat as true, which means that we just need one pass to get the sum. So this is the code. Your input is a sum, and also the root node of the tree. Um, the first thing is you need to check if it's a kind of a no. If it's no, which means it's guaranteed not, means that it's not going to have a an answer. And then if the left and the right are no, which means the summary is actually the root value. And then you need to go either, which means that the input sum is, when the input sum pass into it, it will basically say this is the root value. If it's the root value, means that you are already hit. So this one means that, let's see, okay, uh, following means that you are already hit the leaf node. You need to check if the remaining the remaining value is the equals to the root value, right? If it's not, then you will have it's guaranteed it's not true. Means that it's not the valid pass. Okay. All right. Okay. Okay. Yeah. And then it's going to you need to check if the left side is actually the if let's say this is not leaf node, it has either a left child or right child. I add a comment here. You don't have to check if the left or right is null. If any children is null, then the side will return false, which is going to be here, right? If it's leaf node already get root dot value equals to sum, which means that if the left child is a leaf node, this will not this criteria will not be met, and it will go to here. It will just say, okay, is the passing sum equals to the current value of the node, is the value of the current node, sorry. And then if it is, then this is the pass that we found, and it will return true, right? And in this case, either the left or the right will return true. So yeah, this is and please remember, uh, you just need make sure that either of the left side or the right side return true, it will be true. Yep. So this is the recursive solution. Um, it may have a non-recursive solution, iterative solution, but I will not list here. I will probably post this later if I have time. Hope my explanation is uh, going to help you to avoid your mistake. Thanks for watching, and see you next time. Bye.